Good afternoon. 2 videos in one day, but I'm not going to be talking about computers. No, I got the Air O ear on the bench. So I've got a crazy little dancing waveform there I'd like to show you. Yes, look at it. Now it does it on all my scopes. So it's not this scope. I can short the input and see the baseline is solid. Sawtooth. I'm right off it's a little selenium rectifier right there. Yeah, and I'm right off of that rectifier to the input filter. And there's a discrepancy because this is not the right schematic. My radio is a model 711-AN, and this one is a 711WN. So there is a difference. The 22 ohm resistor, which is right to the right hand side of the diode, in other words the DC side, it's shown there, and then it goes to the input filter, which in this case is 50, but my radio shows 60. But anyways, on the radio itself, the 22 ohm resistor, which is the white one right there, is on the AC side of that little blue block, which is a low current selenium rectifier. And I guess it really doesn't matter whether the 22 ohm resistor is on the AC side of the rectifier or the DC, but it's different from the schematic because it's a different radio. Now this electrolytic here I replaced, and it's not turned around. I'd have to turn it around to see what the value is, but it is not a 50 microfarad. Let me find out what that is. I'll get back to you. Alright, this is a 22 at 160. I remember in an earlier video on this radio, it was a 150 volt rating. So we established that the voltage was over 150, I believe it was 155 or 156 volts across there, so we put a higher voltage in there. 22 microfarad. The one that was in there, I believe, was a 20. So we're still getting a sawtooth. And one that likes to jump around. And every time there's a click or something on the radio, this thing jumps. The radio is going through an isolation transformer. As I showed you in the mod video I made a couple years ago, the case of that isolation transformer is grounded, but the neutral, which was bonded to the case and grounded, is now floating. So this is a proper isolation transformer. You need an isolation transformer. Even though I have a polarized cord on here, I wanted to go through an isolation transformer because my scope is grounded to the line, and it's connected now to the chassis, which is floating through an isolation transformer. Naturally, if the radio had a 3-prong plug, the third prong, the ground prong, would be going to the chassis as well as the oscilloscope. In that case, you would not need an isolation transformer on the radio. So we've gone through all that before, I'm sure. But what bothers me is, why are we getting a sawtooth on this? And it's bobbing, but not any special bobbing pattern. It's just bobbing, and it's sawtooth. The purpose of this video and test is to establish how much ripple we are getting on the electrolytics. Because this is a sawtooth, and it certainly is very unstable. And like I say, it is not the scope. It does the exact same thing on my leader and on this one. The brightness here has something to do with the time delay. I have to refamiliarize myself with this scope, because I know you can highlight certain parts of the waveform, so disregard that. But you can see this thing is bobbing all over the place. And even on the leader. Now that is strange. But why am I getting a sawtooth and a bobbing up and down one at that? It's not a very sensitive radio. It doesn't pick up hardly anything. Even though it's got loop sticks on it, you need a long wire antenna on this. Oh, here's a lot of static in this. Probably silver mica disease. That's most likely what it is. Now watch this waveform when I flip it over to VHF. See how fat it gets? Now I'll switch it off on the other bands. Put it back on VHF. I put the time base up. Time base is all the way up. Turn the volume down. Alright, time base is all the way up. And I've got the sensitivity. I can't see that from here, but it's all the way up. So let's bring the time base back down. Oh, we got the brightness. We got to crank the brightness down. You see, we're getting a double image, and we are okay. All right, we are synced in there. And we are focused in. But that's on the VHF, the aircraft band. There's no antenna on this right now, so I wouldn't expect to get anything. I've got a 47 microfarad 250 volt electrolytic, a Nichicon. Jumped out on the, you can't go by the schematic, but I think it's the second electrolytic there. I can't find my resistor chart. Brown, black, and brown. I think it's 100 ohms. So that's where that is. But you can still see that I've got the same waveform. Now I'm going to shut the isolation transformer off, and we're going to move this wire down to here. Okay. This also goes to ground, to the center pin of the tube socket, and it goes to the ground. Okay, so we put that up. No, that's never done that before. Huh. Found out what happened when I did that little capacitor trick. I'm getting 117 volts over here. And on the input to the filter, to the rectifier, that's what I'm getting, a little over 1/10 of a volt. So the fusible, 22 ohm fusible resistor is blown. Well, I don't have a fusible resistor, but I do have a 22 ohm resistor. But that's not going to solve my problem as to why I'm getting a sawtooth, and I suspect this. So it's a little bit of a dilemma here, folks. I didn't think I'd ruin this capacitor because I didn't put a reverse polarity on it. This is the ground here, and this is the DC side. I'm putting my meter on DC. There is nothing there, and that's why I'm not getting anything on the scope. But the strange thing is, I'm getting 133.1 volts over here. And it is DC, because I don't get a reading when I flip the meter to AC. So over here, I'm getting 133 volts. Now, as far as I know, there's only one rectifier in here, and that's this one. The rest of these guys here are germanium small signal diodes. There's a number of them in here. There's some up here. These are like 1N60s or 1N34s. Okay? So this is the only rectifier in here. So if this 22 ohm, which feeds from the line to the rectifier, it just happens to feed on the AC side rather than the DC side, as I said, but that is strange. Well, I know I blew out the fusible resistor, 22 ohms. This is the white one right there that you're looking at. All right? That I understand. So that stops the DC from coming into this capacitor. That I understand. But why the hell am I still getting DC, 133 volts DC over here? Let's get out the magnifying glass that Steve, a Polish hot dog, sent me there about a year or so ago. I do use it, Steve. Hang on. Okay. As you can see, I hope you can anyways, because I'm using the ZE1. You got the line coming in. Now this schematic does not match this radio. So that's what's throwing me off. I cannot get the exact schematic for my model Air O Ear. But I'm not going to move the camera around too much. But as you can hopefully see, you got the line coming in. You've got your neon bulb with what looks like, with my bad eyesight, 100,000 ohm resistor. Don't quote me on that. I'm probably not reading it right. You got the power cord. You got the line switch. After the line switch, you've got the neon bulb. Then what? Okay. I see something down here. Hang on a minute. Alright, I found an X2 diode. And there's that 20 microfarad, which is now a 22. And that is a 165 volt source right there. Okay, so I have to find that diode. Maybe that is the diode. I don't know, but I gotta check that resistor before the diode. I might be looking at the wrong part of the schematic there, folks. Hang on. So that's a negative 165 volt source, okay? Alright, the electrolytic plus goes to chassis. In order to get your 165 negative source. This end where I got my probe connected is the negative of the cap, because you can see the metal end on the cap. So I hooked it up exactly the way I took the old one out, so that's not reversed. But I'm reading off the negative side of the cap, which is my negative 165 volt source. I just inserted a positive voltage on this. Yes, I did. By taking the cap off of here, see where this big green resistor is? That's where I'm getting my 133 volts. You see, that's a 100 ohm resistor, I believe, just in back of the 22 ohm fusible one that is now blown, thanks to my stupidity. I'm getting 133 volts at that point, and at this point, it's 165 volts, a negative source. Okay, well, I've tried several things. I jumped out this cap. Still get the Sawtooth. I got a bypass across the input filter. 47 microfarads. 250 volts. This is the input. 143 volts. So we got plenty of leeway there. As you can see, we still got a Sawtooth. The only thing I can figure is got to have something to do with these rectifiers. There's one here. And there's one way in the back of the disc cap. But you see that one with the red dot on it? It looks like a mica capacitor. That is the rectifier for the input filter capacitor. This one here, this capacitor here that you see, that's the one I replaced. That is your negative 165 volt source. The original cap, and it was original, never touched, was only rated for 150 volts. This one's 160 volts. And I'm getting 157 volts on it. It's supposed to be a negative 165 volt source, which is right here. I remarked these so I can read them. You got X2, and you got X1. X1 is the rectifier that has the 22 ohm resistor, which was here, but I goofed up and bypassed this cap here, had the polarity wrong. So I've got a 22 ohm resistor sitting here on the bench, but it's not fusible. It's ice cold. The one that was there was blown because I took this cap and put it across here, not realizing that this is 165 volt negative. But anyways, that blue selenium is X1. Okay, so that was my problem before. I had a hell of a time finding X2. Now I'm sorry I can't hold the light and hold everything too, but X2 is right there. Okay? It is that little guy with the red dot on it. So the question is, should I put 1N4007s in to replace this one and this one to get rid of this Sawtooth? I would really like to know if anybody has an air-o-ear radio. Let me turn this off. I'm not getting anything on it. If anybody's got an air-o-ear radio and put a scope on it, are you getting a Sawtooth? Now you saw how it was before. It was jumping all over. It doesn't seem to be doing that now. So we'll remove the cap. You got to turn the time base down. Other than the amplitude went up, it's still a Sawtooth. So that's the situation here. I guess we'll get it straightened out eventually, but I'm kind of leaning towards replacing X1 and X2 with 1N4007. I don't know what the voltage drop is across these diodes. Now the radio, the volume's all the way down. You get very little hum. What you're hearing is the hum from the isolation transformer. That's what you're hearing. More than here. There is a little hum from here. Alright, I'm going to end this video. That's all she wrote.